Aluminium is an abundant element which comprises 8.3% of the Earth's crusts as silicates and oxides and is found in materials such as bauxite. It has 13 protons and electrons and 14 neutrons. It has a face-centered cubic structure with an atomic packing factor of 0.74. And it has 1/3 the density of steel, whilst being ductile from liquid helium temperatures at negative 253.89 to its melting point at 660.4 degrees Celsius. It is a metal, and it conducts very well, both temperature and electricity. It is non-ferrous, and the interatomic bonding is achieved by metallic bonding, where the atoms act as ion cores, and the 3 valence electrons per atom become a sea of valence electrons within the material. Aluminium would make an excellent material for bicycle frames. In 1100 grade, which is the closest to pure aluminium, it has a high elastic modulus when annealed, which is heat treating, and it's not going to deform during use, which makes it a very good application for things such as bicycle forks, which have a shock-absorbing element during use and regularly face cycles of repeated stress. It has a 90 megapascal tensile strength, which is strong for such a lightweight application as a bicycle. It is abundant all over the world, and particularly in subtropical and tropical climates, so it is available both in the first world and in developing countries. However, aluminium does have its drawbacks, and it is expensive to securely and permanently bond, which requires a tungsten inert gas welder, a TIG welder. Cheaper arc welders and metal inert gas welders will not work with aluminium. Lower bonding energy means that it has a 40% elongation, so as a bicycle it should not be exerted to extreme forces or extreme duties. In conclusion, aluminium is a versatile, stiff and tough material, and can face the repeated stresses and fatigue cycles that a bicycle is subjected to, and its ductility ensures this. Whether the bicycle sees stresses and fatigue cycles in the forks, in the seat tube, the down tube, the top tube, the chain stays and the seat stays, when going over rough ground or having riders or items mounted on the bicycle. It is an abundant material all over the world and is accessible in the first and third world countries.
The bicycle frame is the main component that allows the different systems of the bicycle to function together. The important requirements for a material used in a bicycle frame is its strength, toughness, and density. According to Scott Nickel, mountain bike manufacturer, other properties that are important are its stiffness, elongation, and tensile strength. Titanium's atomic structure and chemical makeup provide properties that make it a suitable material for bicycle frames. Titanium is an element classified as a metal due to its atomic structure. The atom has 22 electrons, with its outermost shell containing 2. When bonding with other titanium atoms, these valence electrons are free to drift throughout the metal, forming a sea of electrons, while the remaining non-valence electrons and atomic nuclei form ion cores. These positively charged ions are attracted to and hence held together by this negatively charged sea of electrons, forming the metallic bond. Titanium's crystalline structure provides the material with a smooth surface, resulting in a bicycle frame with a shiny finish. As can be seen in these tables, titanium is a material with a high elastic modulus, high tensile strength, and low weight relative to other materials. This provides a lightweight bicycle frame that will be able to withstand larger loads and will deform less while under load. Titanium is the 4th most abundant metallic element in the Earth's crust. However, the high reactivity of titanium makes the extraction and processing costly. Relative to other common materials, The high extraction costs and the high processing costs of titanium result in the material only being used in consumer products at a premium. Due to this, a titanium bicycle frame becomes undesirable to a regular consumer in the first world on a cost to value basis. Dom Einhorn notes that many people from the lower class brackets in countries like India, Taiwan, and China are forced to purchase cheaper and less durable products when compared to titanium. Because of this complicated and expensive extraction process, titanium is not feasible as a frame material choice in the developing world. In conclusion, the choice of using titanium for a bicycle frame provides an incredible strength to weight ratio, a slick, polished finish, and is limited only by its relatively high price.
Carbon steels are a large group of ferrous alloys containing carbon percentages ranging from 0.29 to 2.1%, and the amount of carbon present in a steel alloy has a large impact on its properties. For example, a steel with a higher percentage of carbon will be harder, and therefore less ductile than one containing a lower percentage. This also greatly affects the steel's modulus of elasticity, meaning a steel with a higher carbon content would be harder and therefore stiffer, resulting in a higher modulus of elasticity when compared with a softer, lower carbon steel. Now, carbon steels have a crystalline structure known as a body-centered cubic structure. Now, this structure consists of one molecule at the center of each cube and 8/8ths of a molecule at each of the 8 corners of the cube, resulting in a total of 2 molecules per unit cell. And metals that are of a body-centered cubic structure are typically harder than those of a face-centered cubic structure, and this is due to the fact that in order for a metal to deform, the planes of the atoms must slip past one another, and this slipping is far more difficult to do in a body-centered structure than it is to do in a face-centered one. Now, steels that are alloys of iron and carbon tend to suffer when exposed to corrosive environments, and this is shown by the galvanic series, where carbon steels are less prone to corrosion than aluminium or zinc, but more prone than other metals such as lead, copper, or titanium. Now, the effects of corrosion, however, can be easily reduced, either through the use of paints that shield the metal from environmental factors, or through cathodic protection. And there are many advantages that steel holds over other metals when its use as a bike frame is considered, one of which being its strength. Now, steel is typically harder and more rigid than other common bike frame materials, such as aluminium or carbon fiber, and although rigidity can sometimes cause an uncomfortable ride, increased rigidity allows for the bicycle to be very durable, and it gives it the capability to withstand impacts that would otherwise crack or shatter carbon fiber or other brittle metal alloys. Another advantage that carbon steel holds over other frame options is its relatively low manufacturing costs. Now, the main cost in steel production is the infrastructure required, such as basic oxygen furnaces or electronic arc furnaces. Now, both types of furnace can be used to create carbon steel, either through the refining of raw materials or through the recycling of scrap metals. Now, this means it would be fairly easy for countries with weaker economies to build these systems and produce steel, therefore making carbon steel an acceptable resource to construct bicycles from in a third world or not as strong country. Overall, carbon steel is a material that is very well suited for the construction of bicycle frames. This is due to a few factors, one of which being the high strength of carbon steel and its preference to bend rather than to break or crack. Another factor is that its susceptibility to corrosion can sometimes be eliminated through the use of protective coatings, such as paints or oils. And although steel is not the greatest bicycle material, it is very well suited for the task.